ion electron configuration. So ions are formed, but electrons are either gained or lost. So what happens to the electron configuration? For example, K is represented by this electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So what's going to happen? Well, we know that potassium forms a +1 charge. So where's that +1 charge comes from? Well, what happens is this electron gets bumped out and it goes to something else. So potassium's happy because it has the last orbital is filled completely with electrons, and this one extraneous electron is given up to make a +1 charge. It has the same electron configuration of argon, okay, which is important to note. Everything that forms an ion wants to become its noble gas counterpart. So that's the bottom line. That is the key point. When forming an ion, it wants to form an ion with the same electron configuration to its noble gas counterpart. So here's an example: Mg and Mg2+. Well, if you do these, you know that Mg has 1s2, 2s2, 2p6, 3s2. Well, in order to make a 2+ charge, it has to get rid of 2 electrons. Which 2 are they going to get rid of? Well, they're going to get rid of those 2. And it has this ion electron configuration, which is the same as, you guessed it, neon. How about sulfur and the sulfide ion, the 2- ion? Well, sulfur has an ion configuration of 1s2, 2s2, an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p4. Well, it wants to fill up those orbitals. In order to do that, it needs 2 more. Okay? So it gets 2 more by adding those 2 electrons, and it becomes a 3p6, which is the same as, you guessed it, argon. So what's the key point? The key point is ions want to become their closest neighboring noble gas. So here's a shortcut in doing electron configuration, and it's called noble gas configuration. It's real simple. First thing you do is you write out the electron configuration for the element. Then you look for the last noble gas passed in the electron configuration. The noble gas will always end in a p6. So match that up on the periodic table. Then place orbitals that do not occupy the noble gas configuration after the noble gas in brackets. So you're going to place the orbitals with those electrons after the noble gas, and the noble gas will be written as brackets. Here's an example. Well, you know that potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Well, I know here, right there, since it ends in a p6 and it's closest to the end, that that's going to be representative of a noble gas. Well, what I'm going to do is I'm going to put everything that has to do with that noble gas in, hang on one second, in brackets. And then I'm going to write everything after the brackets that is not included in the noble gas. So how to write the noble gas configuration looks like this. Brackets argon, 4s1. Here's an example of 3 atoms that I want you to write their noble gas configuration for. So go ahead and pause the video and try it yourself. Okay, welcome back. So what you should have gotten for the answers for the noble gas configuration for sulfur would be brackets Ne, 3s2, 3p4. Bromine would be brackets argon, 4s2, 3d10, and 4p5. Copper is brackets argon, 4s2, and 3d9. I hope you found this video useful, and let me know if you have any questions.